All right, so this right here is logic review. We are going to build a truth table for this one to see whether the argument is valid, because it is not one of the common forms that we know. So it is not using the contrapositive, it's not fallacy of the inverse or fallacy of the converse. So we will go ahead and build a truth table. Okay, now what are we building a truth table for? We are building the truth table for the statement that said premises lead to the conclusion, and the conclusion here is not Q. Premise 1 is not P if and only if Q, and premise 2 being P and Q. Okay, so that truth table, if it comes out to be a tautology, then we would say that, hey, the premises always lead to that conclusion, therefore the argument is valid, because that's what the definition is of being valid. Valid means the conclusion must necessarily follow the premises, right? So let's go ahead and build the truth table. And in this case, we only have P and Q. So there should only be 4 possibilities. So here we go, P and Q. And in the next column, we want to know order of connectives. We'll go inside parentheses first. And then within this parentheses, we would do negation before if then. Okay, if and only if. Okay, so negation of P would be what I'm listing next here. And then I'm going to say not P if and only if Q. And then next, I would go to this other parentheses here. So I would say P and Q here. And then I'm going to go outside of that and deal with this one. Okay, so there would be not P if and only if Q, and P and Q. And then I would go out here, and when I go out here, I'm going to have to do negation of Q before I could do if then. So say here, not Q, and then the entire statement here. Now, the entire statement is of the form 1, 2, 3, 4, 5, 6, column number 6, arrow column number 7. Okay, number 6 right here and number 7 right here. Okay, so there we go. So go ahead and let's list out our possibilities here. We have true, 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 false, false, true, and then false, false. Okay, not P is the opposite of P, so that would be false, false, true, true. And then not P if and only if Q. When we see if and only if, the rule for if and only if is that it would be true if both are true, are of the same value. So here they are not of the same value, so this is false. False, that would be true. Both true, this would be true, and then this right here is false. And so that is the rule for if and only if. If and only if is going one direction true, going the other direction is also true. So the only time that it would happen is if both are true or both are false. All right, now third column is going to be P and Q. So we are focusing on the and mean both have to be true in order for it to be true. So true and true is true. Otherwise, this is false, false, and false. And then we are looking at these two columns here with the connective and, of course, with the connective and again, right? So false and true is false. True and false is false. And then true and false is false. False and false is false. Okay, now I know already that I don't need to know what not Q is, but I'm just going to go ahead and list that out. Not Q is the opposite of Q, so that would be false, true, false, true. Now, the reason why I know that I really don't need to go ahead and fill that out is because false imply anything is going to be true. So this is a tautology, therefore this argument is valid. Okay, the argument is valid in form because this statement is a tautology, meaning the statement is always true. And what statement are we saying that is always true? The statement that said, my premises lead to the conclusion is always true, therefore the argument is valid.